Okay,
Okay,
all
sir.
right. Okay, all right. Thank you. Let's begin today's class with the discussion of numerical questions which were given to you as homework. Elise, do you have any problem? Can you hear my sound? Can you listen to me, Elise?
Sir, my internet connection is not stable.
Okay, okay, please. Okay, okay, please. It will come. Don't worry. Let's begin today's class with the solution of numerical questions. I would like to start from the same question which we were discussing in the last class. This is the principle of hydraulic machine, so which tells large force is produced on large area, even though we apply less force on a small piston. Now, this is the question number one. Dear students, you can see on your screen. The first question over there is name the equipment shown in the figure. The second part of the question is on the basis of which law does it work? And second question is there, calculate the pressure exerted at A, that at A cylinder or at A piston. And the third question is calculate the effort F2 on piston B. So here is the solution. First question answer I have mentioned in this way. The equipment shown in the diagram is, so all of us know, hydraulic machine. The second part of the question is answered as it works on Pascal's law. Okay, let's go to number two question solution. In number two, the question has asked to find the pressure at piston A, so which is a smaller piston. And for solving or finding the pressure, here we have listed some given conditions from the diagram. A force on small piston is denoted by F1, so which is given as 240 Newton. And second, there is cross-sectional area of the same piston, which is small. It is denoted by A1, and it is given numerically as 20 centimeter square. And since in this question, we are asked to find the pressure only on that piston. So why? Force is given in SI system. So for finding the correct numerical value of pressure, we have converted that centimeter square into meter square. Okay, Newton is the SI unit of force. We know the quantity pressure depends on two quantities, force and area. If one quantity is in SI system, so others should be also in the same system. And here we have converted centimeter square into meter square, which is an SI unit. Now we have Newton and meter square. Now by applying the formula for pressure P equal F upon A, and putting the respective values. So force is 240 Newton and the area of that piston is 0.002. So we got pressure as 1,20,000. Later on we express the value in scientific notation in the power of 10 as 1.2 into 10 power 5 Pascal. So in this way we solve pressure at A. Remember here please, okay, you have to take care when we are asked to find the pressure of only one portion, and since we are using the formula F upon A, both the quantities must be in same unit. So Newton SI and meter square SI, then only we can get the correct value of pressure. So third question was there, to find the force on larger piston. And to solve this number three distance, we have used Pascal's formula, or the formula given by Pascal's law. According to the Pascal's law, pressure is equal, so pressure at both pistons, that is A and B, is equal, means that is P1 is equal to P2, and converting that into force and area. So we have formula of Pascal's law as F1 upon A1 is equal to F2 upon A2. So F1 is given in the questions, which is 240 Newton, okay, and A1. So we have converted that into meter square, because in the question A2 is given already in meter square, that is 0.4 meter square. So in this case also, so if we have, okay, area of one piston in SI, or in, let's say, meter square, that other should be also in a meter square. Means 0.4 meter square area of piston B is given in the question. So why we are using 0.002 of small piston, which is also in meter square. So F1 240 upon A1 is 0.002 equal F2 upon, and A2 is from the question 0.4. Finally, we calculate the force on large piston, which is B, equals to 48,000. And this calculation shows that hydraulic machine is a force multiplier. As the area is increased, and obviously force also increases. Get it? Okay, now let's go to a second question, students. And the second question is there. This is also a diagrammatic questions where we can see a spherical vessel that has three pistons: piston A, piston B, and piston C. This A, B, and C. And in the questions, we are asked to find. Okay, we are asked to find the area of piston B, and then a force exerted on piston C. So if you see the question carefully, in the diagram, you can see the force applied on piston A is given, that is equal to 250 Newton, and the area is also given of the same piston, okay, piston A, that is 20 centimeter square. And in case of piston B, the force is given, and you are asked to find its area of piston B. And whereas in piston C, area is given and asked to find out the force exerted on it. So for solving this problem, we will definitely follow the Pascal's law. And here is the solution. So you can see on the screen, according to the questions, force on piston A, so which we have denoted as F1, it is 250 Newton. Cross-sectional area of piston A, which is denoted by A1, it is 20 centimeter square. These are given in the diagram. And force on piston B, that is represented by F2, which is 275 Newton, and asked to find the cross-sectional area of piston B, and that is denoted by A2. That means we are going to find out A2. And for this, we have used the relation from Pascal's law. This is F1 upon A1 equal F2 upon A2. And here I would like to say to you, dear students, please listen carefully. So in this case, okay, if both the areas are in same system of unit, or if the area of any one piston is given in any system, okay, no matter, okay, you can use the same system according to the question. Means in this case, no need to convert that centimeter square into meter square. Since the pressure at both pistons are equal, means the ratio of area is equal to ratio of force. Though we have written in this form, okay, we can write in another way also, just like A1, okay, upon A2, this is the ratio of area, equal and F1 upon F2. So for finding the area of piston B, A2, here we don't need to convert that 20 centimeter square into meter square. Okay, you can use the same number with the same unit as it is, and when you get the answer, you will get definitely in the same unit, that is centimeter square. Understood? So by using formula F1 upon A1 equal F2 upon A2 and putting the respective values, finally we got area of piston B is equal to 30 centimeter square. This is very easy problem. Is in easy numerical. Once we know this equation, that is the equations of ratio of area to the ratio of force, or let's say formula of Pascal's law, we can easily find whether area or force. So in these questions we are asked to find area. So we found area of piston B, which is A2, as 30 centimeter square. Get it? And there was next question, okay, which is asked to find the force acting on piston C, and we denote in F3. So for piston A, we have A2, and for piston C, we have used the symbol F3 and A3. For force, F3, and for area, A3. Now F2, they are already mentioned in the questions. Now any relation we can use, either to piston P or piston A. By using that, we can find the force exerted on piston C. But here I'm using the relation with piston A, that is F1 upon A1 equal F3 upon A3. Okay, A3 is given, right? That is 10 centimeter square here, A3. Cross section area piston is given. This is also in serial system. We are using the same unit and same value. And F1, A1 are also given. F1 is equal to 250, then A1 there is 20. So 250 by 20 equal F3 upon 10. And finally, we calculated force on piston C, that is equal to 125 Newton. Get it? So area of piston B, A2 is 30 centimeter square, and force on piston C, F3 is 125 Newton. And for solving both the problems, so we have used the same rule, same law, or same formula, like the formula of Pascal's law. So in terms of area and force, so whenever you are asked either to find force or area, please always remember to use the formula of Pascal's law, right? That time I was talking about that, just like we can use the right formula in this form also, just like A1 upon A2, okay, equal F1 upon F2. The same formula can be right in another also, students. You can write like this also, F2 upon F1, okay, that equal A2 upon A1. So how you like to write the formula, but always you have to take care. The one thing is there is, so if we have the force on, let's say the big piston as F2, and remember in another side there must be the area of same piston A2. So if F2 is in numerator sub part of first ratio, then in right hand side also you must mention the same, or let's say area of the same piston. So F2 and A2 belong to the same part, same cylinder or same piston. So if we write F2 upon A2 F1, then there must be A2 upon A1. So if we write, okay, F2, let's say by F1 equal, then A1 upon A2, and at the time this will be incorrect, because so A2 is the area of, that is let's say big cylinder, and F2 is the force exerted on the big cylinder. We have considered like that. If you consider so, then this must be in the numerator part as A2 then upon A1. But here for solving these problems I have simply used as, okay, force upon area of small piston and force upon area on big piston. This one F1 upon A1 equal F2 upon A2. So you can go in any way, but just take care, get that the respective force and area of the different cylinders. Now let me go to the third questions. This is the last question, dear students. And the same diagrammatic questions, or let's say similar questions, you can see on screen, and the quantities are given. So in the diagram, as let's say 8 cm square, 20 Newton, that means this is area, okay, and this is a force on piston A, or you can say on cylinder A, and here 320 centimeters square. So area of that piston B, and here F2 is not given. And the first question is there, what is the pressure at A? Means you have to find the pressure at A of this section, of this portion. And second question is there, what is the pressure at A, or B? So after finding the pressure at A of question number 1, I, then in II you are asked to find the pressure at B, pressure of this portion. And last question is there, to find the thrust, means force, which is F2 on piston B, this F2, okay, which is not given in the diagram too. So for this, we have a solution. You can see on your screen. First question, I, where we were asked to find the pressure at A. Let's say pressure on a smaller cylinder, right? The question has given as force, okay, at A, which is denoted by F1, 20 Newton. And I already mentioned you, I already told you when we were discussing that question number 1 also. So if we are asked to find pressure in one part, and we are using the formula as F upon A, so both the quantities should be in same system of unit. In the diagram, the area is given as 8 centimeters square, but cm square is CGS unit. And here the force is given Newton, which is SI. So this must be converted into meter square. So force F1 is 20 Newton, and area A1 is given as 8 cm square. So which we have converted into meter square as 0.0008 meter square. And P1 is what? Using the formula of pressure, force upon area. So 20 upon 0.008 equal, it is 25,000. And in this okay, number also we have expressed this 25,000 number in scientific notation, written as 2.5 into 10 to the power 4 Pascal. So pressure at A is found to be 2.5 into 10 to the power 4 Pascal. Second question was there, okay, that is asking to find pressure at B. So we have considered that pressure at B as P2, and it's very simple, right? We don't need to calculate. So directly by the relation, or let's say according to Pascal's law, so we can say the pressure so exerted on piston B is also that same, so which is 2.5 into 10 to the power 4 Pascal. So pressure at A is 2.5 into 10 to the power 4 Pascal, and according to Pascal's law, so P2 is always equal to P1, because the pressure is transmitted by the liquid which is enclosed inside the vessel. And since that the diagram shows the machine called hydraulic machine, so which is manufactured, or let's say constructed on the basis of Pascal's law. So in hydraulic machine, liquid is kept inside, enclosed, okay, in that vessel, where the equal pressure transmit. So where P2 is equal to P1, and directly P2 is also 2.5 into 10 to the power 4 Pascal. And the last question was there, to find the force, okay, exerted at the piston B. And for this we are using again the same formula by Pascal's law, that is F1 upon A1 equal F2 upon A2. And see here, the area of B, A2 is given as 320 centimeters square, so which is CGS, unit. And here we are given that area A1 as 8 centimeters square. So I'm using the same number, okay, that 8 as it is, and 320. That means 8 and 320 both are in the same unit. So in this case, no need to convert that into SI like that. So 20 upon 8 equal F2 upon 320, and at last we got force exerted at piston B, that is equal to 800 Newton. So did you understand, students, of this? Okay, I will later post this solution in Google Classroom. You can check from there also. But right now, please try to understand that how could we solve the numerical problems related to Pascal's law. Class 10 तिमीले बुझ्यौ अहिले हामीले तीनटा क्वेशन्स जुन डिस्कस गर्यौ नि ओके हाइड्रोलिक मसिनको जुन क्वेशन्सहरु थियो त्यो बुझ्यौ तिमीहरुले बुझ्या छौ है
सर क्वेशन नम्बर 3 मा सेन्टिमिटरलाई चाहिँ किन मिटरमा चेन्ज नगरे
भेरी गुड क्वेशन्स ओके भास्कर जस्तै हामीले लास्टमा जुन 3 नम्बरमा पास्कल्स ल एप्लाई गर्यौ नि अनि पास्कल्स ल भनेको त एरियाको रेशियो र फोर्सको रेशियो सेम हो अनि रेशियो भनेको त्यहाँनिर युनिट क्यान्सल हुने चान्स हुन्छ नि त त्यो सेन्टिमिटर स्क्वायर अपन सेन्टिमिटर स्क्वायर क्यान्सल हुने चान्स हुन्छ हो कि हैन हो भने अब त्यस्तो टाइममा यदि दुईटै एरिया एउटै युनिटमा छ भने त्यसलाई मिटर स्क्वायर लान पर्छ भने छैन है अब प्रेसरलाई क्याल्कुलेट गर्नुसम्म चाहिँ हामीले दुईटैलाई एसआईमा लान पर्यो जस्तै न्युटन अलरेडी एसआईमा छ एरियालाई पनि मिटर स्क्वायर लान पर्यो तर अब लार्ज पिस्टन स्मल पिस्टन केसमा कुनै फोर्स निकाला भन्दा त्यहाँनिर यदि दुईटै पिस्टनको एरिया सेन्टिमिटर स्क्वायरमै छ सिजिएसमै छ भने त्यसलाई कन्भर्ट गरिरहन पर्दैन राइट तर त्यहाँनिर सुन है फेरि त्यहाँनिर एउटा एरिया सेम स्क्वायरमा छ अनि अर्को पिस्टनको एरिया फेरि मिटर स्क्वायरमा छ भने त्यहाँ चाहिँ कन्भर्ट गर्नुपर्छ त्यहाँनिर एउटा मिटर स्क्वायरमा छ अर्को सेम स्क्वायर छ भने त्यो बेलामा चाहिँ दुईटालाई सेम चाहिँ बनाउनु पर्छ कि सेम स्क्वायर बनाउनु पर्यो कि मिटर स्क्वायर बनाउनु पर्यो बुझ्यौ है जस्तै पास्कल्स ल युज गर्दाखेरि त्यहाँनिर एरिया चाहिँ एसआई सिस्टमै हुनुपर्छ छैन एउटै मात्र कुरा के हो भने बेसिक कन्सेप्ट के हो भने दुईटै एरिया चाहिँ सेम युनिटमा चाहिँ हुनु पर्यो कि सिजिएसमै हुन सक्यो कि एसआईमा हुन सक्यो किनभने दुईटै एरिया एउटै युनिटमा छ भने त जस्तै मिटर स्क्वायर अपन मिटर स्क्वायर हुन्छ सेम स्क्वायर अपन सिजिएस हुन्छ त्यहाँदेखि क्यान्सल हुन्छ अनि फाइनली गेट द आन्सर है एउटा मात्र छ भने चाहिँ फेरि एसआईमा लानै पर्छ न्युटन अलरेडी एसआईमा भएपछि त सेन्टिमिटर स्क्वायर लान परिहाल्यो Okay, now class 8, let's go to the second phase of today's class. We are going to start a new topic. A new topic for today's discussion is, you can easily guess, that is upthrust. Okay, that means we are going to start the second portion of the chapter. In the second section of the chapter, we will discuss upthrust, Archimedes principle, theoretical proof of Archimedes principle, experimental proof, or let's say verification of Archimedes principle, and law of flotations with its application. And today we will discuss upthrust only. Okay, Archimedes principle we'll be discussing in coming class, in the next class. So today let's read the new topic, which is upthrust. And to read upthrust, some problem here. Okay, to read upthrust, dear students, let's see some examples first. Then we will come to what is upthrust. Okay, this is the activity or example. So where we can see the existence of force called upthrust. Firstly, take a vessel. This vessel filled with water. This container is filled with water. Then put a ball in it. Simply place a ball inside the vessel that contains water in it. What do you observe? We can see, or we see the ball remains on the surface of water. The ball doesn't go down into the water, it remains on the surface of water. That is, ball is found floating on the surface of water. Secondly, try to push the ball down. So secondly, try to push the ball down into the water by applying the force. So while pushing, we feel difficult. So there is the sensation of some resistance. As we are trying to push ball down into the water, deeper into the water, we experience that some force is acting against us, or let's say against our force. Means we do not feel easier to push ball into the water, right? And anyhow, by applying our force, now we are trying to keep the ball at the bottom of the vessel. We are pushing the ball, and finally we keep the ball at the bottom of the vessel. Now, thirdly, or let's say finally, just leave the ball. So no sooner you leave the ball, again you can see, or you find, or we find that the ball returns to the surface and remains here. Means while explaining this activity, I'm trying to explain three effects we can see in whole activity. The first effect is, the ball simply remains on the surface of water. Second effect is, so we feel difficult to push ball down into the water. And third effect is, when we release the ball again returns and remains on the surface of water. These three effects have one thing in common. That means these three effects are caused by the same agent, and that agent is the force called upthrust. So due to upthrust given by the water to the ball, at first the ball remains on the surface of water, and due to upthrust again given by the water, we felt difficult to push ball down into the water. And lastly, same, due to the upthrust, the ball again returns and remains on the surface of water. So these effects happen just because of the force exerted by the water to the ball, and that force always acts upward. That means opposite to the gravity. So the liquid or the substances give force. So we always try to push that any object kept in that liquid or kept in the substance in upward direction. So that upward force exerted by water or liquid is called upthrust. Did you understand this activity? Right? So we can see more examples like this. Here you can see, this is shown to you, that is on your screen. You can see one example with a picture at the left side of your slide. This is the glass of juice, you can say. So when we are drinking the glass of juice, or let's say juice, or any drink, or let's say any liquid, with the help of this straw, so sometimes, so we feel or we see like that once we release the straw, then we feel or we see that the straw is pushed up. This straw doesn't go completely to settle at the bottom of the glass. When you leave just holding the straw, you can experience that something is there, so which pushes the straw little up, and that is the force given by this juice, you can say drink or liquid, to the straw, and that force is also the upthrust. This is the second example. And third example to the right side of your slide, that is also shown in the picture, you can see wind strength. When we try to lift any object inside the water, obviously we feel easier to lift it. The weight of the object always directs downward, because weight of the object is same to the gravity of heavenly body, right? But when we try to lift that object up, means we are trying to apply the force opposite to the weight of the body, or let's say opposite to the gravity. And similarly, upthrust also acts opposite to the gravity. So when we try to lift any object that is immersed inside the water or inside the liquid, during that time we feel easier to lift it, because of the force called upthrust, there is little loss of weight by the body. Now here the first figure, this one, in this part, though the little portion is out of water here, but if we keep the object complete inside that water, this still is called fully immersed, fully, or you can say completely, or another word there is wholly, WHOLLY, wholly. Okay, these words you have to remember, because these words we have to read in the Archimedes principle. So if we keep the object that is completely immersed inside the water, means the state is it is fully immersed, right? And whenever the little portion is out of water, or say out of liquid, like this, the third picture and the second picture, even in the first picture slightly there is okay, some portion which is out here, and this state is called partially. That means the whole object, okay, that is not kept inside the water. Some portion is inside the water and some portion is out of the water. No matter students whether the object is fully immersed inside the water or partially immersed like this. In both cases, these objects experience upthrust. Okay, these objects receive upthrust. The upthrust is exerted by water. That means the upthrust is given by water, but that upthrust is received by what? That object which is immersed inside the water, or let's say liquid. Right? So either completely immersed or partially immersed. In both the states, whenever that object is immersed, that object always experiences that upward force by the water or by the liquid in which it is immersed, and that upward force is called upthrust. But here I like to add one thing. Please listen properly. So whenever we immerse any object completely, means that is the state of full immerse, right? In that case, that object experiences more of thrust. I'm talking about the same body, okay, not different body with different densities. So if we have same objects, when we immerse that body completely, means fully immersed, okay, at that instant that body experiences more of thrust. So if I show, okay, the body in this case, like in this state, let's say completely immersed, and another the body in this state, so partially immersed and wholly immersed. So between these two states, okay, in this state the body experiences more of thrust, because of thrust is the force, so which depends on the volume of, okay, immersed part of the body, that is volume of displaced liquid. That means here the upthrust exerted by water on it is more, and in this case the upthrust exerted by water in it is less, because most of the part, or let's say some parts of this object is out of water, only the small volume, okay, but here complete the whole body is inside the water. So more of thrust experience and less of thrust experience. This is for the same body. Okay, if you have different bodies with different densities, at the time the body with less density has more of thrust, okay, that is experience. We'll discuss later in when we read Archimedes principle and its theoretical proof, right? Just okay, by showing these pictures and examples, I'm trying to say to you, so there is the force given by the liquid or even gas, okay, on a body, and that force is called upthrust, and by its name, okay, by the name of thrust, so we can easily say that the direction of that force is always upward, means against the gravity, right? So let's learn what is upthrust. So we can say the strength of thrust is the resultant force, or you can say resultant upward force exerted by a fluid. And here fluid means for both liquid and gas. Okay, liquid also gives upthrust and gas also gives upthrust. So comparatively, liquid gives more of thrust and the gas gives less. Both gives. That means exerted by fluid on a body. So when the body is wholly or partially, see the two words come here, wholly immersed or partially immersed. In both the cases, that the liquid exerts upward force on that body, and that upward force is called upthrust. So why does liquid or even gas give upthrust, exert upthrust? Okay, because that is just due to the difference in pressure at different height. So in enclosed vessel, so if the pressure transmits from some point, and we say that pressure transmits equally in other points or in all directions, we say. But in case of liquid, so kept in some vessel or somewhere in river or sea, so the liquid pressure changes with the height of liquid column. So at the bottom, liquid pressure is obviously more, and at the face surface, liquid pressure is less. So due to difference in liquid pressure at different height, and the liquid is able to exert the force called upthrust. So we'll prove when you read the formula for upthrust, you will be busy in Archimedes principle, right? Now here, let's go to another topic, students, that factors affecting upthrust. The formula for upthrust, okay, here we have is U equal V, this is capital B, students, and D and G for calculating upthrust exerted by liquid is given by the relation U equal V dg, where U stands for upthrust, okay, that is the force that is measured in Newton, and V for volume, okay, volume of submerged part, which is equal to the volume of displaced liquid. So how much part of the body is immersed inside the liquid, and that much volume of liquid is displaced. Everybody knows, you know, the liquid displacement method, right? And D for density, okay, and this is the density of liquid, right? This is the density of liquid. So if you have two types of liquid, for example, one is water, another mercury, and if we are asked to say which liquid has more upthrust, and obviously we say mercury. So why, students, mercury is able to even float the iron nail on it, right? Because the density of liquid also determines the upthrust.